Hi guys, welcome to your flip video that's going to be looking at function notation. For this video, you will need the foldable that you are provided with in class. So what we're going to do is be going through this foldable together. So we're looking at the foldable that's function machines and function notations. So the first thing says that a function can be thought of as a blank that assigns blank to blank. So we're going to fill that in, and we're going to say that a function can be thought of as a machine that assigns one output to every input. So as we're working with functions, you'll hear a lot about function machines. Because if you think about a machine, you put something in and it spits something else back out. So what we're going to do is we're going to look at the different parts of a function. The first part of the function that we're going to look at is the f right here. So the f, I think about that as just the name of the function. So we're naming this function f. We could name this function g, we could name this function h, it doesn't matter. The next part that we're going to be looking at in our notation is the x. So the x, or whatever is in parentheses, tells you what letter or number to plug into the function. So we could plug in the number 5, and if that was the case, we would put 5 in parentheses. Alright, the next thing that we have is the f of x. So the f of x is just the function notation. So f of x is the same thing as y. So it's like if you told me that y was equal to 3x plus 4, it's the same thing as telling me that f of x is equal to 3x plus 4. However, f of x is the notation that you'll be expected to use in Math 1. And then the last part that we have is the 3x plus 4, and the 3x plus 4 is just what we call the function. Alright, what we're going to take a look at the bottom of the front page is we're going to find and illustrate f of 2 and f of negative 1 by using the function machines. So what you see here are these handy dandy little machines. In the machine, our function is 3x plus 4, so you want to go ahead and write that down in your machine. For the first one, remember the f says the name of the function's f. The 2 tells us what we're plugging in. So as you can see here in green, I'm taking the number 2, I'm putting it into this function. So in place of the x, we're going to plug a 2. So we're going to do 3 times 2 plus 4. When we do that, we get 10. So what you want to do is you want to tell me that your answer is f of 2 equals 10. And again, this means that we put 2 into the function and it spits out a 10. Looking at the next one, we're going to be finding f of negative 1. For f of negative 1, I know that I need to put a negative 1 into the function. We're going to plug negative 1 in for x, and I'm going to give you just a second to figure out what that gives us. So when you plug negative 1 in, you should get a positive 1. And then when we write our answer, we don't want to just say the answer is 1. What we want to do is we want to write out our answer as f of negative 1 equals 1. And this means if I look at the function f, I plug in a negative 1 and it gives me out a positive 1. So what we're going to do next is we're going to be looking on the inside of the foldable. On the inside of your foldable, you'll see lots of examples. We're going to do some of the examples together, and then you'll have to finish the rest of them on your own. Alright, so inside of your foldable, you'll see that f of x is x squared plus 3, and g of x is x plus 1. So we have two different functions here. We have the function named f, and we have the function named g. So the first question that we're going to do is the first one right here. So it's f of 3. So this means I'm going to go and I'm going to find the function named f, and I'm going to plug in the number 3. So I went back up to the original. In place of that x, we're going to put a 3. So that's going to give us 3 squared plus 3. When I evaluate that, I get 12. So double check that, make sure that you get the same thing. Then to write our final answer, remember we don't just say the answer is 12. We're going to write our answer as f of 3 is equal to 12. Alright, the next example that we're going to do is we're going to do the f of 2 plus g of 1. So here we have two different functions. We have f and we have g. It's asking us to evaluate f of 2 and evaluate g of 1 and then add those two quantities together. So what I'm going to do is I'm actually going to come off to the side and I evaluated f of 2 and then I evaluated g of 1. So looking at f of 2, you can see I went to the function f. In place of the x, I put in my 2. I evaluated that and I got 7. I'm going to slide that over just a little bit so you can see it better. And then for g of 1, in place of the x, I put in my 1, so I got 2. So then when we go to solve our f of 2 plus g of 1, f of 2 I know is 7, so I'm going to plug in 7. G of 1 I know is 2, so I'm going to do 7 plus 2, and that's going to give us 9. So then to write our final answer, we're going to say f of 2 plus g of 1 is equal to 9. Again, this would be the same thing as if I just asked you to find f of 2, then I asked you to find g of 1, and then later I asked you to add them together. Alright, the next example that we're going to look at down here is our f, and we say this f of g of 2. So it's a bunches of f's and it's a bunch of g's. So what we're going to be doing is we're going to be looking on the inside of this function. So on the inside, you see g of 2. So while this looks like really crazy function notation, we're going to take this piece by piece and actually be able to evaluate it. So the first thing that we're going to do is we're going to, in the middle, we're going to evaluate g of 2 because I know how to do that. So g of 2, I go up to the function g. In place of the x, I'm going to put a 2. So 2 plus 1 gives me 3. So since g of 2 is just 3, this is the same thing as just asking me to find f of 3. F of 3 is just like we've done in the previous examples, so I'm going to give you a moment to go through and evaluate f of 3. So for f of 3, I did 3 squared plus 3, and that gave me 12. And as my final answer, we would write that f of g of 2 is equal to 12. Alright, the last one that we're going to take a look at on this page is f of y. So f of y is telling me to go to the function named f, and I'm going to plug in a y. So all this is asking me to do is actually switch out the letter x for the letter y. So instead of x squared plus 3, our function is going to become a y squared plus 3. It's not telling us what y is equal to, it's literally just telling us to put in the y variable. So that's all that we have to do. Remember, you're welcome to rewatch the video to go back through these examples. Alright, so looking at the last page, I'm actually going to leave the first two examples for you to do on your own, and what I want us to look at is the very last example on the page. So it says, if f of x is equal to 2x minus 5, which expression represents f of x plus 1? So we're going to treat this just like we did the previous examples. If I'm being asked to find f of x plus 1, I know that that means I'm looking at the function named f, and I'm plugging in x plus 1. So I'm going to go over here to the function f, and in place of the x, I'm going to put an x plus 1. So instead of being 2x minus 5, as you can see over here, I put my 2, in place of my x, I put my x plus 1, and I have minus 5. So once we have this, what we're going to have to do is go through and solve it. So we're going to use the distributive property to distribute our 2, and that gives us 2x plus 2 minus 5. We can combine like terms. When we combine our like terms, we get 2x minus 3. So for this example, our correct answer would be A. Alright, so don't forget that you are required to finish the remainder of the foldable. So all of the examples that we did not do in the video, you are required to do and bring to class with you.